Hello everyone. In this session of CCNA series, I'll discuss two STP protection mechanism, root guard and loop guard. When spanning tree calculates the topology of the network, it is based on the location of the root bridge, and any switch with the lowest bridge ID will traditionally take over the role of the root bridge. Okay, so what is root guard then? Root guard is a STP security feature used in Ethernet networks to enforce the position of the root bridge in the STP topology. So why this root guard is used? It is useful for protecting a rogue switch being deployed in the network and attempting to become the root bridge, thereby protecting the network's STP topology from being altered. Let's see how it works or how is it implemented. To understand why it might be useful, let's consider a small topology with three switches. Switch with the lowest priority becomes the root bridge. So we have configured switch 1 to become the root bridge. Imagine some hacker or some unknown user adds the switch with lower priority than switch 1. That switch will become the root switch, or that switch would try to be the root switch, and that could be harmful for your network. With spanning tree root guard configured on those port, this is what is going to happen. So when the port with root guard enabled receives a superior BPDU indicating a better path to the root bridge than the current root bridge, it places the port into error disabled state. So when you configure root guard on those port where you are expecting, or where you don't want to expect any root switch to be connected, when you enable root guard and if you receive a superior BPDU, as soon as it receives that BPDU, it will put that port in error disabled state. So once the port with root guard enables stops receiving BPDU, it will unblock the port. So no manual intervention is required. So root guard is enabled with interface command spanning tree guard root. So let's look at some of the consideration while using root guard. Root guard should not be enabled on port that serves as uplinks to other switches and that are intended to participate in root bridge elections. For example, the interface between switch 2 and switch 1. So root guard is a valuable tool for maintaining a stable and predictable STP topology by preventing unauthorized root bridge elections. So let's move on to another STP protection mechanism called loop guard. The spanning tree protocol plays a crucial role in ensuring a stable, loop-free network in Ethernet-based environments. So the primary role of STP is to prevent loops in a network with redundant paths. So in this topology, if you see, STP elects a root bridge, which becomes the central reference point for all path calculations within the network. The switch with the lowest bridge ID, that is a combination of priority and MAC address, is elected as the root bridge. And the second best becomes the backup. For that, STP assigns every switch port that participates in STP and assigns certain roles and states, such as root port, alternate port, and designated port. So let's look at some of these ports and roles. Designated port, the port on each network segment with the best path to the root bridge, is called the designated port and is placed in the forwarding state. Then we have root port. The port on each switch with the lowest cost path to the root bridge is called the root port and is also placed in the forwarding state. The switch can have only one root port. If you see in the topology, switch 2 and switch 3 have root ports. The root switch will always have a designated port. And the third type of port we have is alternate port. The alternate ports lead to the root bridge but are not root ports. The alternate port maintains the STP blocking state. If you see, the switch 3 has a alternate port. The connectivity between switch 3 and switch 2. One port is on the left side. Between switch 3 and switch 1 is a root port. On the right side, if you see, GI is 1023, it's an alternate port. So any port that does not participate in the forwarding process is placed in a blocking state to prevent network loops. So this is how STP resolves physical redundant topology into loop-free like or tree-like topologies. But the biggest issue with STP is that some hardware failure can cause it to fail. Some hardware failure such as unidirectional link failure can cause this topology to fail and create some forwarding loops, which can cause some major network outages. So the STP loop guard feature provides additional protection against layer 2 forwarding loops. So this is where the loop guard comes into picture. The STP loop guard feature provides additional protection against layer 2 forwarding loops such as STP loops. So an STP loop is created when an STP blocking port in a redundant topology erroneously transitions to the forwarding state. In the previous topology, if you see, our GI 1023 was in blocking, alternate port role. So here if you see, due to unidirectional link failure, the port has moved into designated role. So this usually happens because one of these port of physically redundant topology, not necessarily the STP blocking port, no longer receives STP BPDUs. So in its operation, STP relies on continuous reception or transmission of BPDUs based on port role. So the designated port transmits BPDU and the non-designated port receives BPDU. So here, since it was not receiving any BPDU, it transformed itself into designated port. So let me take an example. Here the switch A is the root switch and switch C is the least prioritized switch and has one of its port between port switch B and C in alt port role or in blocking state, as we saw in the previous slide. So for normal operation, STP relies on continuous reception, as I said, or transmission of BPDUs based on its port role. So due to some unidirectional link failure between switch B and C, switch C stops receiving any BPDUs. Now without loop guard, let's see, the STP blocking port on switch C transitions to forwarding state, and what will happen is this will create a loop. Now with loop guard enable, the blocking port on switch 3 transitions into STP loop inconsistent state. If you see the difference, without loop guard, it will become designated port and cause a loop. But with loop guard enable, it will move into loop inconsistent state. So in this state, the port does not pass user traffic, so a loop is not created, and the loop inconsistent state is effectively equal to, I would say, blocking state. That's it for this session. I hope this was informative for you. Thank you for watching.